Okay, finding the opposite of a number. This goes along with what we were talking about in the first part of the sections 1.4 and 1.5. Okay, two numbers that are the same distance from 0 on a number line but lie on opposite sides of 0 are called opposites or additive inverses of each other. Okay, for example, opposite of -8 would be +8. Okay, these numbers are also called additive inverses because if you were to add them together, their sum would equal out to be 0. Okay, so the general rule is if a is a number, we say then that the opposite of -a is equal to a. Okay, this goes right along with what I was talking about on the previous handout as far as eliminating your double signs. Okay, if you look at these examples, you may have some questions on the homework that just say simplify, or they might actually say find the opposite of a certain number. Okay, so if I have a negative minus a -22, to simplify that, this means the opposite of -22, which is just +22. Okay, just what we were talking about on the previous sheet about eliminating double signs. So if it's a variable, if it's an x, same thing, minus a -x means the opposite of -x, which would be +x. Okay, now remember there is a big difference between parentheses and absolute value bars. Okay, remember in section 1.2, the absolute value is always positive. The absolute value is how far that number is from 0 on the number line. So if I were to cover up this first negative and just say I wanted the absolute value of -18, that portion would just be +18. But because I have this negative out here, my overall answer would be -18, because this actually means the opposite of the absolute value of -18. Well, the absolute value of -18 is positive, but opposite that would be -18. So it's real important that you see the difference between the absolute value bars and just the parentheses. Okay, the parentheses are just separating the two negatives, but those bars actually have a meaning there. And so this is the only time that you'll see two negatives together with your answer actually being a negative. Okay, we most of the time think about, when we have two negatives, it's going to be a positive, but this is the only exception to that. Okay, the second half of this sheet deals with evaluating algebraic expressions using real numbers. Now we've done this before also in section 1.3 where we evaluated for different values of a variable, but this is the first time that you're actually going to be replacing the variable with negative numbers, okay, and using your order of operations. So example 2 says evaluate each expression when x is equal to -5, y is equal to -2, z is equal to -3. So in the place of x, I'm going to put -5, have a minus sign already there, and in the place of y, I'm going to put 2. So I end up with this problem, -5, -2. Use my sign rules, which means the signs are the same, so we add and keep the sign. So my answer would be -7. On B, you have x squared minus z. So again, when I put in this -5 for x, it's always going to go in parentheses. When you plug in a negative number, it's a good idea to put it in parentheses if it's going to be raised to a power. Okay, so -5 squared minus z, which I'm going to replace with the 3. So now we have to think about order of operations. We have to do the exponent first. -5 squared would be 25, positive 25. Bring down -3. Signs are different. This means I subtract, which would be 22. Keep the sign of the higher number, So positive 25 means that my answer is going to be a positive 22. Okay, and on C we have the absolute value of x minus a negative 6 over 3 times y. So first thing I'm going to do is just replace negative 5 in the place of x, bring down everything else, over 3 times y, which is 2. Then I have to go back and simplify what I have inside the absolute value bars. So that means I have double negatives that I have to eliminate. So I would have the absolute value of negative 5 plus 6. So those two negatives I'm going to change to a positive. Over, I could go ahead and multiply, that would be 6. Okay, still in absolute value I would have negative 5 plus 6. The signs are different. That means I subtract. Keep the sign of the higher number. So I actually have the absolute value of 1 over 6. Okay, I kept those bars there because had this been a negative, I still would have to clear out those bars. So the absolute value of positive 1 is just 1 over 6. And then that's not going to reduce any further. So that would be your final answer. So with evaluating expressions, you will have sometimes where you'll be plugging in negative numbers. So you're going to use those same sign rules that we've been talking about earlier in these problems.